You're listening to the Thesis Review podcast. I'm your host, Sean Wellick. On the Thesis Review, I'll interview researchers from around the field, centering the conversation around their PhD thesis. In addition to exploring the technical content, this will give insight into their history as a researcher, allow us to revisit older ideas, and provide a valuable perspective on how their research and the field itself has evolved since their PhD days. How do we ensure that large language models are safe and respect privacy? My guest today is Niloofar Mireshghallah, a postdoctoral scholar at the University of Washington. Niloofar completed her PhD at UC San Diego in 2023, where she focused on auditing and mitigating safety risks in large language models. We talk about her journey into research, including her unique perspective growing up in Iran, and then go into her thesis work, discussing how privacy is defined in the context of LLMs, common attacks that these models face, and the role of differential privacy. We talk about methods that she developed for privacy auditing, mitigating privacy risks, and talk about the balance between memorization and generalization in language models. The Thesis Review is available on SoundCloud, Apple Podcasts, Google Podcasts, and Spotify. If you're enjoying the show, please leave us a 5-star review on Apple Podcasts, and be sure to follow us on Twitter @Thesis Review. To support the podcast, go to patreon.com/Thesis Review, or make a one-time donation at buymeacoffee.com/Thesis Review. If you're a business or an angel investor interested in supporting the Thesis Review, please also get in touch. We recorded this interview in 2023, roughly 1 year ago, so you'll notice that occasionally we'll mention things that are about a year old. I apologize for the delays, but I'm excited to get the Thesis Review started again. There are links to the thesis and the papers that we mentioned in the show notes. Here's Niloofar Mireshghallah with Auditing and Mitigating Safety Risks in Large Language Models on the Thesis Review. Yeah, so thanks for coming on the Thesis Review. Yeah, I'm really excited to talk about your work in the thesis, as well as just privacy and language models in general. So maybe as a lead-in towards that, we could just talk about how you got started in the field and started in research. So even before your PhD, what was your initial interest in doing research and then eventually in doing a PhD?
Yeah, well, first of all, thanks for having me. I really appreciate it. And I'm glad that I can kind of talk about the interdisciplinary area of privacy and NLP. It's always, good to put them together. So I started doing research in undergrad. So I always wanted to, I really liked, teaching and mentoring and everything. So I always wanted to be some type of a teacher, at some level. So I don't know, maybe from high school or junior high. And to be perfectly honest, I am from Iran, and in Iran, if you want to leave the country and if you want to do it in an academic way, the PhD is one thing you do. But I feel like I was one of the luckier people who actually wanted to do a PhD. A lot of people just do it because they want to leave the country. It's I'm being very honest. But yeah, so I knew that I wanted to do a PhD, and I also in general liked research. When I was in junior high and high school, there was this astronomy program with joined with NASA, and we would put stuff together and collect data, and I really liked snooping through things and finding patterns and stuff like that. So I felt like I kind of started realizing that I like research style things. And then when I was in undergrad, it was kind of the path because everyone was also doing it. Everyone would join a lab, do research, and then apply for a PhD. So I was kind of also following others in that. My undergrad was in hardware. So I actually, I was in hardware engineering. And the first research project that I worked on, I honestly had no clue what it even was. I was working with a master's student, and he would break everything up to little pieces. So I didn't even know what the thing we were doing is. I was just coding up little things. And then after a few months when it all came together, I realized, oh, so this is the whole goal. And I actually really, really enjoyed that. It was on not at all related to any ML or anything. It was on fault tolerance, redundancy for fault tolerance in real-time systems. So it was a completely embedded system design. And then when I applied to PhDs, I was applying under computer architecture, and yeah, and like I ended up like joining a lab like at UCSD, which I was deciding between UW and UCSD. Actually, I feel like I was always kind of supposed to end up here, and like every step in my life, it was like it didn't happen, but like finally it did. But yeah, I joined a computer architecture lab, and I was doing computer architecture. Like the first few months, we were working on compression and quantization for neural networks to get them to run faster. And part of quantization is to add noise. It's like you basically like discretize things, which is like kind of equivalent to like making the network noisy. And as I was like looking into papers and doing literature review on like all people adding noise to networks and stuff, I came across differential privacy, which also like adds noise during training. And I was like, oh, like this is cool. So I started like reading on it more, and just like privacy through randomization and obfuscation. And that's how kind of like in the by the like towards the end of my first year of PhD, I really got drawn into the privacy aspect. Like just I went kind of from quantization to privacy. And I liked it because it had to do with people. Like you have to consider what people, believe is private or not. It's more people facing rather than like architecture, which was like very low level. So I kind of decided to just like start, venturing out and like doing more privacy rather than architecture. It
Hmm.
started as doing efficient kind of like architectural based privacy, but then it kind of just became privacy in machine learning, and then privacy in NLP. Yeah.
Yeah, yeah. Yeah, that's really cool to hear because I think like sometimes, especially starting out, and I mean, even as an experienced researcher, it feels like we always have to be able to predict, like, okay, I'm doing this, and therefore I'm gonna like be doing this in the future. But like, I think like what you kind of said is that you kind of just start working on something and like get experience, and it might be interesting to you at the time. And then there's kind of this like unexpected link that like when you're compressing these networks, you add noise to them, and that ended up linking to privacy, and you kind of drift in that way. I think that's really cool.
Yeah, it was. I feel like I got lucky that I found what I liked like that. Like, I mean, I liked doing what I was doing before, but then I was like, "Oh, I really like this better." So, yeah, it was kind of lucky. Yeah.
Hmm. Yeah, so then the topic of your thesis, so the title is Auditing and Mitigating Safety Risks in Large Language Models. So could you just like introduce the idea of privacy and language models? What are some of the risks? Maybe what are some of the challenges that come up with these models?
Right. Yeah. So the thing is, like, first of all, even in the definition of like how you define privacy for language, we really don't have a consensus or like a good definition yet. Because what people are doing right now is that like we're taking privacy definitions that existed for like tabular data in the statistics and machine learning, and we're kind of like, okay, trying to like stretch it to fit language. Same people like vision people have done it to like stretch it to like fit vision. But the difference, like what makes language even like more different, is that with like tabular data, you have this nice definition of, okay, this is one data record. It has like multiple rows, so it's like clear, like the amount of information in the in each record is like it's very well defined. You have these like atoms of information. And then the privacy definition that people normally use is differential privacy, which basically says you want to, it's like the kind of upper bound, like most strong like notion. You want to protect like every aspect of everything, so you want to protect the membership of each like record. So
Mhm.
what it entails is that, oh, like if I get any kind of a statistic, like be it a machine learning model or anything, out of one data set, and then statistics out of another data set where only one record is different and it only differs by one feature, I want these two statistics to be like indistinguishable. I want there to be like plausible deniability for it. So like that's a really nice definition, and it's like there are nice algorithms that do it, and it's like it fits the problem really well. Like U.S. Census uses this for like releasing data on populations and stuff. But then when people like took this and applied it to like images, still with images, you have images like every record is like it's an image that has a certain size. You have pixels, and like pixels have continuous values. So again, you can like kind of take that definition, stretch it a bit, and like apply it there. But then when you come to language, it becomes different because it's no longer continuous. You have like discrete, you have like the vocabulary. B, it's like how you define a record becomes very different. Like
Mhm.
sentences have very different lengths, and then even the information in sentences could be like different. You can have a short sentence that has a lot of information, or like a long sentence that like doesn't have a lot of information. And also it's like really hard to like detect duplicates and correlated samples, because like you have forms and meanings, and like you can say one piece of information in so many different ways. Whereas like in images, if you have like, I don't know, L2 distance, it's kind of like, you get a sense of how similar two things are. So it's like way easier to like get the similarity in a sense. Well, I'm sure there are nuances to images too. I don't want to like I'm sure I don't want to like really assume a lot, but yeah, that's like one of the things that makes it harder for language, is we cannot define this record. So then defining any kind of guarantees on top of it becomes like really really hard. And all of this gets coupled with, again, it's not continuous. And even when you get like embeddings, then you have like these huge models in like high dimensional space, that it becomes really hard to like just like define, like if you add some noise, it's not gonna like change change the actual word to anything new. So it's like it's harder to like basically define and take exactly what we had there. But that is what people are doing. So like we're still stretching the existing. We just like we're like, okay, every record would be a sentence, and the fact that sentences have different lengths, I'm gonna like kind of relax that and be like, okay, it's okay. So we are
Mhm.
using it, but it is difficult. It makes it kind of like not interpretable. They're like, oh, the guarantee that I'm getting, like what am I really protecting? So like that is kind of one of the main challenges in defining privacy. And then also for measuring, or like just like measuring leakage of models. So what I mostly focus on in my research, and like I feel like it's an important nuance, it's like the difference between like security and privacy in models. So like people sometimes, like people from outside the fields, they're like, oh, like what's the difference between encryption? Why not like encrypt everything? So like encryption is kind of like you build a wall, you build like this secure tunnel that you don't see what is happening, but everything gets sent and operated as it is, like in its raw format. It's just kind of, you're like putting on like a protective like firewall or something. But with like privacy and leakage, you want to make sure that like when, especially again, the part of it that I focus on is like if I'm training a model or I'm extracting something out of it,
Mhm.
nothing can leak. So it's like there's no hint of what was in the training data. So when you're training something with encryption, there is like a key that like if you don't have it, you cannot see what's happening in the model. But then once you have the key, memorization could still happen in a large model, even if you're like encrypting. So that's why you need the differential privacy, or like privacy, like memorization kind of controlling methods to like make sure that like nothing is leaking into the model. And with
Mhm.
LLMs, with large language models, like the main problem is that they're like really huge, so like they have a high capacity for memorization. So you also end up with like getting more memorization, like compared to like smaller models. And another problem is that we don't really like have control on their training data fully, so there's not transparency there, and they're scraping the web, and there's like a lot of leaked information on the web. Like I mean, there's not proper consent in a sense. So that's also something that like makes it like hard to just probe and analyze. So
Mhm.
yeah, I feel like these are kind of the things. It's like you have the yeah, on the one hand it's just like the models are memorizing more, and on the other hand we don't even have good definitions. And I feel like another problem in general though with like when you are working on privacy in like any aspect is there is this whole disconnect that like there are people who want to move state of the art, and there's no like privacy by design. It's like, okay, we'll do it, like privacy people will come clean up after. Like we just want to like get the like best model, get the best performance at like no matter what cost. And there is no legislation really either. I mean, we're seeing more lawsuits now, but you know it's like way behind in terms of technology. So like as people
Mhm.
are like putting out the next model, the next big thing, like here, like with privacy, if you like see, like we're still trying to attack GPT-2 and like extract sentences, and it's like it's yeah, it's a bit sad, but yeah, that's another thing. It's like
Mhm.
always it always takes precedence to just like build the next state of the art model than
Mhm.
like think about any kind of risk, not just privacy of the model. So yeah.
Mhm. Yeah, I see. And then, like, in terms of just for those who aren't familiar, what are some just like simple examples of like real world situations where these types of privacy risks would come up. So with something like memorization.
Yeah, so so like cases, this like a very very easy way to test it, and like anyone could do this, is like if you use the GitHub Copilot. So like when you're like, I don't know if you use like VS Code or whatever, like if you use GitHub Copilot, even if you're not trying to extract stuff, it's like really easy. You get full strings of data regurgitated. So like that's one of the biggest problems, is that you get verbatim regurgitation, or like very similar in terms of like approximation regurgitation of the training data. And it is like more so of a problem when, like, let's say if you're like email prediction, like like you're using Google and you're typing stuff, you get a prediction from like someone else's like emails. That's a huge problem. These things, they normally don't happen with like Gmail or things that are trained on actual personal data, because they put a lot of filters on it. Like they make sure that like it's like a huge problem. But then with the GitHub Copilot, because it's all collected from GitHub pages and technically they're public, you actually see how well, I mean, the conceptually it's the same thing, right? It's like if you don't care at all about privacy, it's like you see how well it regurgitates the, both with code and even text. Like we were once at one of our group meetings taking notes, and like one of my lab mates was trying to like write a script for like his proposal, and he was like, hi, I'm, and then like we got this full chunk of text, like one full paragraph. There was someone's name, and like I'm like a PhD student at MIT, I do this, and we were like, what? And we Googled it. It was true. It was completely correct. Like it was someone, it was their page, their affiliation. I think their affiliation was off, but their research area was correct. Like everything else was about this person. And again, it is on their webpage. So it's like, it's okay. But it just goes to show how easy it is to memorize and like just extract these things. So I feel like
Mhm.
the most obvious kinds of attacks on this sense are on code based models, especially because they're not natural language and they're like, everything is extremely unique. So it's like you see more, I've seen like extractions work better and like memorization like more in those models. But it, people like have tried and they have like extracted like sequences from GPT like XL and like other models too. But it's just like harder. You really need to like dig deep. But with GitHub Copilot, like anyone could just like, I don't think they've even like really tried to fix it. They have put on some filters. It's really funny to just like run things by the training data and make sure that they're not regurgitating verbatim. But then there's also work that shows that like if you take like a sequence and you just like translate it to another language, you do end up getting the verbatim text from training data, but also translated. So it's called
Mhm.
like a style transfer kind of extraction, where you like change one thing and it just regurgitated in like in the new style, but it's the same. Yeah, it's the same content. So yeah.
Yeah, I see. So then that starts to get into the difficulty of language, where like suppose we protect against like exact memorization, then there's like ways around it, like translating or like
Yeah,
rephrasing or things like that.
yeah,
Yeah.
it's a choose your own adventure kind of thing.
So then, yeah, going to the adventure of your PhD. So the first section is on, it's called privacy auditing.
Right.
Um, and you looked into this area of membership inference. So we've kind of, I guess, uh, like loosely mentioned this idea of inferring uh, which training data is in a model. But yeah, maybe you could just start talking about like what you did in your PhD work in this area.
Yeah. So yeah, like one, in order to just like understand and like mitigate anything, you like first kind of have to measure it. And for like memorization, for like measuring memorization and leakage, there's different ways that people are doing it for like language. Especially like this year, I'm kind of happy to see like more papers coming up with like new definitions and stuff. But an upper bound, like the strongest attack that we have, like the by principle, it's like called the membership inference attack. So this attack, it's literally kind of the definition that tests like differential privacy. It also tries to infer if a certain record was part of a training data for a model or not. So if I give you a model and I give you a record, if you want to run membership inference, you basically try to make a guess, make an educated guess about whether that point was used to train this model or not. And it's not by default a privacy risk on its own, because this assumes like you have access to a record, and many times you don't like even know where the training data came from. But it is a problem in like two senses. Like one sense is that like assume a setup where you have like a medical kind of model that is supposed to like prescribe people with like the amount of insulin they're supposed to take, like it's for diabetic patients. And if you know that like Alice's data was used to train this model, just the fact that you know this data, even if you don't know what the record was, but you know that it was used to train this model, gives away one bit of information that, oh, Alice has diabetes. So that is the leader. So that is why it is a problem. But even like apart from that, it is even like in a language model where it's like way lower stakes in terms of like one sentence. It is a good proxy just for like knowing what the worst case leakage of a model is going to be. So it's like, once if you have like an optimal attack, then you know that, oh, like this model is like, at worst gonna like leak this thing. So it is a good measure that like practitioners can use just to like have an idea of like how much data their model is leaking. And these there are like different types of these attacks, and they're like the people started like mounting them on deep learning models since like 2017 and stuff, and like for small MLPs, or like, and then it was like vision models, and like a bit after there were like a few works that mounted them on language models, like in specifically generative models where you could get like likelihood of a sentence. So the whole intuition behind most of these attacks is that they rely on the fact that if a sequence was used in the training data of a model, it would have lower loss, right? Because you've seen it, so the loss is lower. And like a lot of people just like use this intuition, but then the problem is like, again, people have seen this like in different setups. Like the one of the papers that I did, we particularly like focused on how it happens with like mass language models, but it happens like in everything else. Is that one problem is you sometimes have sequences that are like outliers, or like for any reason the model doesn't fit to them well, so they might have high loss, but that doesn't mean that the model didn't see them. So you end up with like a lot of false negatives, in a sense that like it is really in the training data, but you're going to say that it's not. So in order to mitigate this, what like the literature in like security like did like from years before was to try and recalibrate this loss based on some intuition on like how complex a sample is. And the way that like we did it was like we used a reference model. So we were like, okay, if I have another model that is trained on data that is kind of similar, but not the same, and if I feed this sample to that model as well, if if it has like, if it's really a difficult sample, and if this model has also not seen it, it would have a way higher loss. So you basically kind of bring a reference model to help you calibrate for how hard a sample is, and then like this really helps like get better precision on the attack. So and there are different, this is called a likelihood ratio based attack. It's kind of the state of the art right now, but the problem is it's hard to mount these with language models, because you need good references, and like you need a pre-trained reference, and like, yeah, we have some pre-trained models on Hugging Face, but then again, it's not really, you cannot easily adjust the pre-training and like get your own model. So it relies heavily on having a good reference model, which is not necessarily always the case in like when you're working with natural language. Like it's, you don't always get good models. So we also did like another paper where we were like, oh, how can we like get rid of this like reference thing, and just look at the loss of them all and decide. So we were like, oh, let's look at the curvature. And our intuition was that, oh, if you like plot the loss around a point, so if you perturb it a little and plot the loss, you would be able to tell based on the curvature if a point is a training data or not, because training data like probably has higher curvature, but like non-training has like, it's like, it's not, there's no curvature. You have some points like higher, lower, so the lower curvature in a sense. And we showed that, oh yeah, this could actually be like as effective as likelihood ratio based attack, when you don't have like a good reference necessarily, and you just need to like make a guess. And the funny thing about that is that like at the same time, another group of people showed that this could be used as a machine generated text detection method. So they also were like, oh, if something is generated by a model, it's like there's high curvature around it. If it's generated, like if it's human written, there's no curvature. So same exact membership inference attack could be used to differentiate between machine generated text and like human written text, which is like kind of interesting. But yeah. So anyways, Yeah, so that's on the auditing. There's like also a lot of other auditing methods. Like you could try and do extraction, you could try and do property inference, where you're like, I give you a model and you try to guess properties of the training data. So it's like not you're like, oh, like 50% of the training data was probably from like people of, this kind of descent, or like from this ethnicity. So if you can infer a property of the training data without actually finding a data point, that's also an attack. But again, all of these attacks are kind of weaker than a membership inference, because like the membership inference is like it tries to literally extract even a single bit of information if it's leaking. But for property, like you need more bits, or like for a full extraction attack, you actually like need to get a lot of training data out. So yeah, but there are many different ways to like audit models.
Yeah. I really like this. So this idea of like you have some baseline, so you have this reference model, and then you can look at the ratio of your model versus the reference model's score essentially on the sequence, and then use that to kind of infer whether your model has it in its, or whether the model you're kind of attacking has it in its training data. The variation on it that you mentioned, was that like really recent work?
So you mean the like the one where we were like looking at curvature?
Oh, sorry, the curvature. Yeah.
Yeah, this was like so we published it at ACL, so I was like just there presenting it last week. But because of the anonymity period, we didn't like archive it, so it was technically from like February, so it's like, kind of recent. But it was like exactly around the time that like Detect GPT used the same method for predicting, like, again, training data versus generations versus non-generations. So this is very recent, and I've seen people just like starting to look at curvature. It's like funny, like people from different fields like suddenly started perturbing points and looking at the loss. Again, we were doing it for privacy. I saw people do it for like for machine generated text detection, and I also saw some people like start to look at it for some like fairness and bias purposes, just to like based on the curvature figure out like what points are like being underrepresented or like mistreated basically, and not treated with equally. So it's interesting that like it's kind of like, yeah, people at different fields are like, oh, let's like look at the second order derivative of the loss, and like maybe the third order, so it's really interesting just to like how much the loss manifold can tell you about either membership or like what is a generation or not. And it's also like a really simple idea, right? Like you take a point, you perturb it, you like plot the loss based on it. The only problem is like it's really important. Like in the likelihood ratio based attack, your whole success was contingent upon having a good reference. Here, your success is extremely contingent upon being able to generate good neighbors. So neighbors that
Mhm.
are actually like very close to the point. Because if you go with far away neighbors, they're all gonna like have lower like likelihood. You're gonna end up with just high curvature for everything. So it's not gonna work. So like we also observed that it's like really important to like generate good neighbors. And the best way we found for it was that like we do masking and resampling. So we take the sequence and we perturb it by masking like sub parts of it, like some tokens of it, and then regenerating it. And it's really best if you use like a very large, like a really good model. Like we've used T5 3 billion to do and like we found that that's better. And like as you use like worse models, like you can see that the performance of the attack gets worse. So there it's really important to like get very close. We also tried getting close using the actual embeddings, but I feel like it's this thing where you also don't want to get too close, because the surface of the loss is very like, it's like very, is it
Hmm.
jagged? Yeah, it's like very sharp. So like if you get too close, you're gonna like end up with like a lot of fluctuation. So there is this sweet spot that the whole attack like relies on. So there's no like really good attack that you're like, oh, this is gonna always work. Like there's always like, you need like some necessities for things to pan out well. But yeah.
Yeah, that makes sense. Yeah, I was also thinking through this idea of the membership inference, or like trying to get a memorized, or trying to get a sequence from the training set. And I was wondering like whether there's like some difference between trying to extract something from the training set, or trying to prevent against something being extracted from the training set, and trying to prevent something that the model outputs. In the sense that like you could have, let's say in the training set, you check whether like Alice lives in Manhattan is in the training set,
Right.
and it turns out to not be. But like Alice takes the one train from 110th Street every morning or something is in the training set. And then with like a really good language model, if you then prompt it to say like Alice is from blank, then it might actually just infer that she's from Manhattan. And so in that sense, like the sentence Alice is in Manhattan isn't in the training set, but you can still get a kind of privacy violation when you go to generate with the model.
It's like, in a sense, you have like a hierarchy of things. Like, you might not have like Alice like is in Paris, it might not regurgitate that, but it might regurgitate that Alice is in France or like is in Europe, something like that. Like it
Yeah,
could.
yeah.
That's interesting. Well, yeah, that's really cool. I so what we well the thing that like people first try to do is to just like get verbatim memorization.
Mhm.
And it's yeah, I haven't seen anyone looking at the like approximates like that and actually checking if you are getting extractions that are kind of like semantically like mean the same thing, but it's not actually like the same thing. The closest thing I can think of is the work I told you with the whole like translation and like it's called
Mm.
like style transfer kind of prompting, where they try to like bypass actual like verbatim, like in code generation models they do this. They change the language, or like they change the style by they make it like, instead of like actual code, they put the like hashtag comment thing, or like the percentage thing at the beginning of things to get it to like
Mhm.
regurgitate the same thing, but it's usually a different style or like a different language. I've never seen it be done for like kind of like a hierarchical sense that like it's like something that is a shared aspect of it. That's really interesting. Like that could be in 2020, like the first paper that actually extracted a full sequence out of GPT-2 like came out by Nicholas Carlini and other collaborators. And what they did was they did this whole they did sample and re-rank. So they took 500,000 samples from like the GPT models, and then they re-ranked it based on a membership inference signal. So they were like, oh, we will like look at this. And they took the like they also like they had many different signals. So they took like some of them and like they re-ranked everything, and then the top they narrowed down their pool to like, I think, a pool of like 3,000 sequences or something, and then they ran it by OpenAI. Like they had collaborators, they were like, okay, we think that these 3,000 sequences were in the training data, and they gave it to them, and I think it ended up being like, I don't know, 2,000 or 1,600 or so of them were actually in the training data. So the precision of the attack is kind of good. You get around 60% precision. But the thing is, you extracted 500,000 samples to get like 1,600 verbatim regurgitations, where most of the regurgitations were like just like hashes or like
Mm.
URLs or like weird things that didn't like. There was a couple sequences that had people's phone numbers and stuff in them, but yeah. So it ended up like, and that's kind of the type of attack that people do right now, is to just like sample and re-rank. And one thing that like we tried to do back then was like, oh, how can we make this more efficient? So we were thinking of like using membership inference signals for decoding. So because like there are like controllable generation methods and like constrained decoding, so we were thinking that, oh, let's like do the decoding but optimize for a membership inference signal, like optimize for likelihood ratio. And when we tried that, what ended up happening was we were getting generations that the reference model hated more than the target model. So it was like just gibberish that one of them hated more. And then we tried to like regularize it. Like we did a bunch of tricks and it didn't work. And what it came down to, which is like interesting, but also kind of expected when you like hear it, is that models tend to like their own generations better than the training data. So when you take
Mm.
samples, like models like the samples better. Therefore, like you really cannot use membership inference signals to differentiate, because all of them are just going to be higher on some very likely generations. So we found that it's like really, really hard to use those signals in order to actually like, we were like, oh, we want to like traverse the loss function and like find the, find the peaks or whatever. You would get stuck at generations and not the training data. Like we literally saw
Mm.
that like, oh, the training data is like close, but it's not even like, it's not, you cannot nudge it to get out of there. So it kind of didn't work at that point. But one thing that like we never really studied was the things that we were generating, how close, because we only did verbatim matching. Like how close are they to training data? Like maybe, as you were saying, like maybe it's like it subsumes it, or like there is kind of a relational thing there. We never studied it closely. But then we did the neighborhood attack like this year, and we revisited it. We were like, okay, let's like use this as a signal. And the same thing, it's like still generations have like higher signals, so that's also not working. But we are looking at it again with some collaborators in UW. So that's a really good thing. Like I'll ask them to check to see if, because we were looking at partial overlaps now. We're like, okay, we agree we cannot get verbatim, but let's see how much overlap we're getting. But it would be really interesting to see if like the entities that we are extracting, if there is like kind of like what you said, like the streets in Manhattan, or like if you can infer properties, that's really cool. That's a very, very good idea. Yeah.
And yeah, it also yeah, hopefully the listeners are following, but I just realized something. So it actually makes sense then that this curvature attack works for the membership extraction as well as um, identifying what's been generated by the model then, because you said like in both cases it's assigning really low loss.
Yeah, exactly. And that was like really cool. When I saw it, I was like, wow, this is really cool. And then I tried likelihood ratio for machine generated text detection, and that also works. So it's kind of like membership inference attacks and like machine generated text detection methods could be used interchangeably unless you're detecting between training data and generations. That kind of like, then the membership inference attack won't infer the training data, it will infer the generations. So in a sense, generations from a model are adversarial examples for membership inference attacks.
Hmm.
It might be a bit complicated, but I don't know, I think it's a cool little thing. Yeah, yeah.
Mhm. I wanted to ask about the next part of the thesis, and it was again on memorization. You had this really fascinating plot, and it was looking at the kind of training trajectory of the model, and you identified these three phases. So one was kind of learning and maybe small amount of memorization. Then it like shoots up and starts doing a lot of memorization, and then there's overfitting. So yeah, I just that seems so cool. So I don't know. I don't have a specific question, but maybe you can just
Yeah,
talk
yeah,
through
no.
that.
That was like it's kind of, some works, like it's really funny. Like I have some papers that like I put a lot of work into, but it's like, okay, it's good. Like, and then there's some papers that was just like one idea, one moment, maybe I spent a month on, and it's like it ends up being like really nice. So that was like one of those papers. It's like a short paper. We spent like maybe like 4 or 5 weeks on it, because it was kind of coupled with another work, and as a side quest we were like, okay, oh, this seems cool, let's try this as well. And we submitted like both of them to EMNLP, and I was kind of hoping that the other paper would get more attention and stuff, but this short paper got a spotlight talk and everything, and I was like, well, really, was it that interesting? But then, yeah, I realized that people really like it, and I think the thing that, like, the thing with that paper, and like it really, one thing that clicked for me is just like the different ways that people from like different backgrounds look at the same thing. So for me,
Mhm.
like I mean, I'm not claiming I have like a privacy background, but I started doing privacy before I was doing NLP. So for me, it was always like, okay, memorization is like bad. We do not want to memorize. Like even most privacy people will tell you, like, you don't want your model to memorize. You want it to generalize, and you end up memorizing tails for some reason, or like to generalize. But mostly you want patterns. You don't want you don't want memorization. And that was like always in my head. So when I was like plotting that thing, like, I was like, okay, the first phase, and the utility that we're looking at, it's kind of the generalization gap. So it's like next word is perplexity gap with like, on the test set. So it's like, oh, perplexity is going low, that's good. And then the part where it like shoots up and it's only memorizing, in my head, that's like really bad. I'm like, okay, I'm not getting anything better on perplexity. Like the perplexity is like literally flat, and I'm only memorizing the samples, and then it overfits. And so the thing was that before this, there was actually like another paper, like, I don't know, it was it in like EACL or ACL the previous year, where they actually said that, oh, because of this whole plateau thing where perplexity is not getting worse, you can actually like stop training whenever you want. Early stopping doesn't matter. But we were like, oh no, it actually is memorizing. So if you look at the memorization is getting really bad. So early stopping does matter. You really want to stop early. And that was how I was thinking of it. Like, I don't want memorization. So, it's kind of like you have the three phases and you want to stop early. And then I was presenting that in my defense, and Samir Singh like said something really interesting that I don't know why it had never hit me before. He was like, well, and I was saying that this is bad, we need to stop training early, and he was like, well, this is only perplexity, like maybe some tasks actually need memorization. And I was like, what, but like, and then it like, I kind of like paused there, and then he was like, yeah, like, a lot of factuality and like closed book Q&A tasks, you like really want everything to be memorized, and like the fact that you're measuring perplexity does not like, it doesn't align with all the tasks that you're going to be using on these models. And there I was like, oh wow, like he is right. So it kind of started this question in my head that there is like, especially in NLP, there is good versus bad memorization, which is something that you don't really see in other domains. And like, it's still when I like talk to some privacy people and I'm like, yeah, like we sometimes need memorization and like it's actually like very different. They're also like, oh, like that's really interesting. It's like, we never think about it like that. So that was one of the like interesting outcomes of that paper for me, was that I like, again, the plot is, it is what it is, like it is what, but I feel like if I went back and redid that paper, I would write a discussion on how, like, because in the paper the tone is that, yeah, it's like really bad, memorization is going up, like privacy is just like really like going, it's not good, you should not do this. But I feel like I would add this discussion that, oh, like you should be careful like what task you're using this model for. It's like, if it could be a task where like you really need memorization, so maybe like we need to like kind of differentiate our training set into like what is good to have memorized or what is bad to have memorized. And like I would maybe do the plots a bit differently. But on the other hand, there's this whole discussion that if a task really relies on memorization, like it's like closed book Q&A, like factuality, stuff like that, then you don't necessarily care about privacy, because it's like, I don't know, like it's on Wikipedia or something. So you could also say that, well, those tasks, you don't even care about privacy. So there's this whole, motivation behind it too. But yeah, that was kind of the story with that paper, that it is true that you end up memorizing and it shoots up, especially because the data set is small. Like with fine tuning sets, they're super small, so you end up memorizing really fast. But sometimes you need it. But for me, in that paper, another thing that really caught me by surprise was the fact that fine tuning the head was so bad, because it's something that, like, when you're training classifiers, you take a pre-trained, like your Roberta or something, you put a head on it, and then you only train the head. It's something that people commonly like do. You don't train the full model, you only train the head. And we found that that's like really, really bad in terms of privacy utility trade-offs. Whereas like using adapters or like other kind of efficient fine tuning methods that are not like all in one place, I feel like we found that like, a, having all your trainable parameters be in like one blob is not good, and b, especially when that blob is at the end of the network, it just makes it worse. And I think that was also like an interesting finding with that paper. But yeah.
Yeah, I see. So yeah, I think here the main topic was doing the fine tuning with like different methods, and then
Yeah.
it is kind of, yeah, it is weird that like usually we think that if you have like a small amount of parameters like right at the end of the network, then maybe that would actually guard against memorization. But then that turned out to be kind
Yeah,
of the
exactly.
most
It was actually
susceptible.
worse. She's really
Yeah.
interesting. Yeah.
Yeah, this really got me thinking. It was really interesting. Like it seems like there's three things going on. There's memorization, and there's memorization, generalization, and then privacy. And so like some memorized sequences might actually be good for generalization, like factual knowledge. It's like you shouldn't like magically reconstruct something, or like even like 2 + 2 = 4. It's probably good to just memorize that instead of like actually doing the addition. But then like some memorized sequences violate privacy, so then we probably don't want those. And so it seems like there's some kind of like they all get tangled up, and then yeah, there's like maybe some inherent tension between the
Yeah,
different
there's
things.
definitely some tension. Like when it comes to evaluating like LLMs, especially, I feel like it is, people don't really talk about how tasks could like inherently be at odds with each other. Like I feel like this is one of those cases where like it's really hard to disentangle it. And everyone is like, well, if it's facts, then it's different. But it's like when we're training all these models and like no one cares what data is going in them, they are together. Like, you can't be like, oh, factuality models are like different from like models used in companies, so it's fine. Like, no, like people are not in practice caring about it. They're just like throwing all the data and just like, so yeah, I think it's the whole problem of like good versus bad memorization is like really interesting to think about. Yeah.
Hmm. In these different projects or like in your own research, how do you typically like find things to work on? And then, at least for me, there'll be there's like doing the search, but then you might end up with a lot of search candidates, and it's still a matter of like choosing which one to work on. Do you have anything to say like in that area?
Yeah, so it's it's also kind of similar for me. Like I end like some projects and I'm like, okay, like I need to like brainstorm for a new project. And normally it's like you go on like a couple of weeks, you have no ideas, and then suddenly you have like 10 candidates and like, oh, which one am I gonna do? Um, in my PhD, I think like what I was doing, especially because like I had a really weird PhD journey. Like the first 2 years, I was like in a computer architecture lab, and then for like some reasons, I left it, and then I actually started doing NLP in an NLP lab, but I still wanted to do privacy. So it was for me. It has always been weird because what I've always done is different from what my advisors do. So I
Mhm.
don't typically get the like, oh, the advisor gives me an idea and I just like roll with it. I really have to like come up with the idea and like make sure that it's doable. So I've definitely had like at the beginnings, especially when I was just doing it, like I had moments where I would like choose a project and then it would be like infeasible, or like, I would be like, oh, like, is this really a good idea or not? But normally things that work with privacy at the like, if you're just like trying to start doing it, it's always like you can always have this like genre of work that you're like probing something. And it's like, oh, you take existing attacks, there's always new models coming out, and the speed at which people like probe them is like very 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 lower than the models coming up. Like we have new architectures even right now, there's like S4 backpack, all of that, and no one has like really looked at memorization in those. So like one
Mhm.
kind of thing that I sometimes do, especially like if I'm trying to like scope a project to like do with like to like do mentoring, it's like these kinds of probings because it's like lower stakes and it's also like interesting. So that's like one way I go about it. I also had like I did a lot of internships with Microsoft. I did like four and a half, like I did like five internships. So sometimes they would come up with like, it would be like, enterprise based like problems that they would have, and then we would work on them. So that's also like a part of where things came from, was like real problems that they had, and we like kind of simplified it to a research kind of a researchable small problem. And then and another thing is just like, I feel like that's one of the blessings of being like in an interdisciplinary area. Like I talk to like security folks, and then I talk to like NLP folks, and there's a lot of things that you can just connect. Like, you see a new method come up. Like I was at ACL and I saw this like initialization method that like helps initialize the weights, with unigrams, I think. And then I was like, oh, like this could be like altered to do it with differential privacy and actually get a better initialization for differential privacy. Because like on the other hand, talking to like DP folks, I know that they really care about like initializing models. So it's like, like I see one thing here and I'm like, oh, this new method in NLP could actually be used to like make differential privacy, like, mechanisms better. Or like vice versa. Like I see something in DP and I'm like, oh, this could actually, like be used here. So that's also something, there's like a lot of transfer that could be done. That's another way that I come up with things. And but I feel like just like talking to people is also in general really good.
Mhm.
Like we talked that day in the kitchen, and you told me something about the impossible distillation paper, and I actually like it kind of triggered something, and like I might be doing. Well, I'll talk to you about it, but like something with an undergrad on it. But like it could actually be used to make DP mechanisms more data efficient. So like that was something. It's just like sometimes when you talk to people, it's like it really like clicks something. And yeah. So yeah, both like, maybe if I want to sum it up, it's like from industry and like just the typical, grab this method and probe it kind of thing, which is like always the simplest thing to do. And just like, going to talks and just talking to two different communities, I think it helps you not get tunnel vision, because I think when you're only in one community, you're really bound to get tunnel vision.
Mhm.
I think it's really important to, like, when I go to conferences, I actually more try to go to like tracks that are not my main track. And I just like, I really want to just see what people are doing, and I think that really really helps. Yeah.
Mhm. Yeah, I was curious with privacy. It's kind of like separate from the way things are traditionally divided up in the sense that like in any given machine learning domain, there's probably like a privacy aspect to it. And then there's like non-machine learning stuff that has to do with privacy. Yeah, do you see what I mean? And so what is it like as a researcher? Is there kind of like a shared knowledge that, or not knowledge, but is there like a set of things that you kind of have to learn and then you talk to someone and you're like, "Oh yeah, I work like more on language specifically," or
Yeah, that's a good question. I feel like as you mentioned, there's like a lot of aspects to it. Like there's this whole HCI side of it that, oh, what do like go do research on what people actually want out of privacy. And then there's all these works on privacy policy legislation, is like all of that. And I feel like one of the important things to know is like when you are like choosing what you want to do and stuff is to learn the basics of it. Like I feel like for me, just like learning DP, like I took a while to actually like learn differential privacy, kind of learn the math behind it. I'm not like, again, I'm not from a theory background, so it was like really hard. And I don't think I've ever like really, not ever, but like I don't think I'm at a point where I would be like, oh, I can come up with new DP mechanisms and do like all of the accounting, because it is like really, it's non-trivial. But I think it's important to like have the like proper like training for it. There's like a lot of resources. And then B, it's also good to just be aware of the societal aspects, like just follow the like lawsuits, follow the legislation, because there's like also a lot of ideas coming out from that. Like when GDPR came out and they were like, they had
Mhm.
this clause of right to be forgotten, which was like, oh, the instance like I want something out of a model, they have to like take it out. Like that opened this whole research area of like machine unlearning and, like guarantees for like data deletion. And before that, it was kind of there as a form of editing, but no one ever had to like give guarantees. But now you had to like make it more like in a nice framework way. So I think that like that's also another thing, is like when you like look at the actual real world problems, it kind of like opens up new research avenues, which is interesting. But again, I think like having the educations and actually seeing what people have already done in that field is important, because I do sometimes see this thing where like people in one field, they try to like, not about like, I'm not like a specific thing, but like they try to, I don't know, do privacy, and they really don't go and see what others have really done. Like privacy people are not just sitting there not doing anything, like, things, they are doing stuff. So it's like really important to like go see the prior work, see what people have done, and then like build on that, as opposed to being like, okay, I want to do privacy in this thing, like the first thing that comes to my mind, I'm just going to go do it. I think it's really worth like taking the time when you want to start in like a new field, to just like familiarize yourself with the like literature of it. Like for me, I had this thing with crypto where I was like, I felt like because I'm doing privacy, I have to at least understand what's going on. And I really tried to like learn the like homomorphic encryption, all of those, like how they work. It was too difficult. I was like, okay, I'm not doing crypto, not that much I know, but I respect them. Like, shout out to people who are doing crypto, and it's not going to be me for now. But yeah, so I think it's good to focus, but also just keep a broad like connection with like everyone, talk to people from like different fields who do similar stuff. Yeah.
Mhm. Yeah, yeah, that makes sense. Um, well, yeah, this has been really great so far, and I guess we're only getting to like the second half, but we should definitely mention the like the other side of things, I guess. So we've been talking about these kind of attacks or auditing, but then when we actually think about like mitigating privacy, I guess that's what the next part of your thesis is about. So could you just talk through like what are some high level strategies for mitigating the privacy risks?
Right. Yeah, yeah. So one thing that I just like about doing privacy is like when Chat GPT and everything came out, like people were like freaking out. Everyone was like, "Oh, like what happens to research? Like, what are we gonna do?" Like, because a lot of the fields, like people who did like semantic parsing, or like a lot of the tasks suddenly kind of, they didn't get solved, but they were really good. Like I did like a style transfer on like a couple papers, and like this does a style transfer really well. Like you don't need to do style transfer, or even with controllable generation. So like there was this whole thing that like it affected everyone so much, and like it's warranted. But then I feel like the part of my research that I like is that like you can actually like easily adapt, and like there's a still things to do, like there's a still like things you can audit, and like things you can do. And like a good thing is like, oh, if you don't like have access to a lot of resources, like one problem even before Chat GPT was that like there were large models, like yeah, Chat GPT came out, but there were large models before it, and you had to train it for everything. And a lot of people like don't have compute, right? Even in the US, like at UCSC, we didn't have that much compute. Like I couldn't pre-train models. So the good thing was that like a good part of like everything that I did in the auditing like area was like I did not have to train a single model. Like I always took models from Hugging Face. All I did was run inference, which like makes it more accessible. So I feel like it's something that anyone can do. You can just grab models and just like run inference on them, and you don't need to train, which is like really nice. But then for mitigations, it's a bit different. You do need to like train models at this point. and how people do the mitigations. Again, this kind of, I guess it does get divided between the chat before and after chat GPT or GPT-3 era, because
Mm.
when you were training your own models, like you're fine tuning it on data, you're like deploying the model and you don't want anything to leak, right? So that the whole point is that when people make queries, you don't want anyone's information to leak. And um, again, like everything else that I've kind of discussed, you would use differentially private mechanisms which have guarantees. And what it entails, like you don't even need to know the math. Like sometimes I feel like like it freaks people out when I'm like presenting DP papers at NLP conferences. I try to make it look as benign. It's like I tuck the math away in part of the like one part of the poster. I don't even like talk about it. If someone asks, I'm like, oh, this is how the math works. But it's very simple. You just like clip gradients during DPSGD and add noise. It's like it's sorry, during SGD, and just add noise. And really that's it. So the clipping of the gradients intuitively limits the leakage for each sample, and then when you add noise, you're obfuscating it. So you're limiting the leakage and obfuscating, and that's how you end up with a model that like whose leakage is like limited because of the clipping of the gradients and the addition of noise. It can be really bad. You end up like losing a lot of like accuracy on underrepresented groups because it smooths out the tails. Again, by default, it's supposed to hide the membership of each record, right? And underrepresented folks, they have fewer records, so they end up getting smoothed, but you end up preserving the mean of the distribution. So that's kind of how it works. So you get the main statistics out of it, but anything particular or unique gets smoothed out by the noise. And that's how you
Mm.
like get your guarantees. And the problems, like it brings some problems, like it has an like a fairness issue. It like gets rid of the modes. So if you have multimodal data, it like you're not going to get good distributional representation for them. And it's for a long while there was this problem that you have to do this like clipping of the gradients and addition of noise on a per example basis. So you cannot really do batch clipping and addition of noise because you want to make sure that you get guarantees for each example. So this whole
Mm.
per example thing makes it super slow. People have come up with new methods. There's like ghost clipping, and then like if you use JAX, it's way faster. But still, training with differential privacy is much slower than doing normal SGD. So that's another problem with it. But yeah, but the basic thing you do is like you add noise and clip gradients during the training, and that's how you get a differentially private model. But for a while before 2021, people did not really do it that much because it like when you're clipping gradients and adding noise, it really gives you bad privacy utility trade-off, especially because it's like trying to give you like worst case guarantee. So it tries to protect everything, and not everything always needs protection. So there was I actually like have a paper, and there's a line of work like kind of parallel to the differential privacy stuff where they try to limit memorization through other signals during training, like through adversarial learning, where you have like a classifier that tries to distinguish private data, and you kind of backprop through it and you like change your model so that this classifier like fails. There's other ways people do kind of like triplet loss based, where they like try to take two like samples from one person and make them as far away as possible so that you can't link it back. So based on some like heuristics, there are works that like try to just like add noise to parts of the data, or like or do like kind of adversarial learning and all of that. But again, these methods would not have guarantees, and it would be warranted before we had pre-training. Like right now, one thing that people have found is that when you do differential private training, DPSGD, on top of a pre-trained model, you actually get really good privacy utility trade-offs. So like
Mm.
right now, it is actually does make sense to like use DPSGD and like train with privacy easily and get good trade-offs. But I feel like before that there was like again there was like this line of work that tried to limit memorization with other than DP methods, which again made sense because like DP was like really bad in terms of like utility. But right now we're in a state, at least with language, because we have like foundation models, like we have models that are like pre-trained and like we can like fine tune on. So I think that really helps, and like it has made research easier. But yeah, it's mainly like these two methods when you're training. There is this whole area of scrubbing too, where you actually like scrub PII, like personally identifiable like information from the corpus before you even do training. A lot of regulations, like HIPAA regulations, require that they have 18 categories of data that you scrub before training, and then like that way you're sure that they don't leak. But that's like kind of like separate from training time, time like methods. So the TLDR, I guess, is to use differential privacy at train time, and that's how you get like leakage limited. Yeah.
Uh-huh. What comes to mind is, so you mentioned this like wave of GPT-4, and now it seems like there's another wave happening with the kind of open source movement where we might not be able to get the absolute best performance, but we're able to get like pretty reasonable models. And depending on the method, you do need some GPUs, but there's even like the hope that you can actually fine tune these things. And it seems like in the privacy setting, that might actually be a good fit because you might not want to rely on some API, and you might actually be wanting to fine tune your model. So do you see like maybe there's still a lot here to explore with kind of these new open source large scale pre-trained models?
Right. Yeah. That that's a good point. I feel like they definitely help just like getting a better trade-off. But one thing that I'm seeing more, I mean, I don't know if it is large scale models, how exactly people are more likely to use them. I'm getting a
Mm,
sense that everyone is just going towards prompting and in context learning right now. I don't know if like fine tuning on data is still like a thing that people really do that. I guess they do it, but I don't know. I've just seen prompting, like you put a bunch of examples in a prompt, and then you just like do in context learning, and like you get predictions from it, or like you first instruction tune and then do this. So for that scenario, like then this is like better in terms of privacy because you're not actually fine tuning the model on the private data, so it's like it's actually not going to leak it, which is really
mm,
good. And like one thing actually with like DPSGD is that when you do like fine any kind of fine tuning and you do differential privacy on top of it, the guarantees hold at every step of the fine tuning. So at any step you can technically release the model. Whereas like we normally just need them all at the end, right? So it is kind of wasteful in that sense, but that's how the algorithm works. But like now that people do prompting, there's like better things you can do. So like right now you put your examples in the prompt, right? So there's no training happening, but you still put potentially private examples in the prompt. But the good thing is now you can actually do the decoding with differential privacy and make sure that your examples like that are in the prompt don't leak, which is like
mhm,
it's like very recent. Like a couple of papers came out like last month. There's actually literally two papers on this. We're doing a paper right now that like we're like basically looking at how does this whole new paradigm of in context learning, which doesn't involve gradients, how it can like induce leakage like from the prompt to the output. So I feel like that might be something that is becoming more relevant right now. But again, with new large open source models, I guess yeah, if people continue fine tuning that's both good and bad. If they
mhm.
do it with like it's good, but then but it's you will get better utility privacy trade-offs if you just put the put the examples in the prompt and just do in context learning, because you're not really, the parameters aren't changing. So yeah. But again, like everything that comes like brings about a bunch of problems. So like it's like good, but then the prompt could leak, and then you're giving your examples to OpenAI, so like they could like use them. So yeah, it's
Mhm.
yeah, it's there are problems. And there's no one solution basically. Yeah.
Yeah, yeah. So yeah, maybe we'll go to like the present and the future. Um, so yeah, so now you're doing a postdoc, and when you think about the type of research that you're doing now or in the future, kind of where does your PhD work sit, or where do you think it'll be in the kind of long arc of your research career?
Yeah, I feel like um well, I again, like I feel like I was kind of lucky that with this whole chat GPT stuff, my entire thesis is not obsolete right now. Part of it is I did not realize it until like I was invited to give a talk on like one work that I did, which is not at all privacy related. It was like uncontrollable generation. And the minute like I had talked about that work like a bunch of times before, and the minute I started talking, everyone was like, why not have chat GPT do it? And I was like, okay. And then like every 5 minutes someone would ask that, and I was like, and then I gave some answers, like there are some valid answers, but then I was like, oh god, there are people whose whole disease is like this, and is that what it's going to be when they give talks? Like everyone is just going to be like, why not have chat GPT do it? So I feel like at least in that sense I got lucky. But one thing that like I want to do, kind of like an overarching goal of like my research, and like I feel like I kind of got here because of the stuff that I did in my PhD, and I realized that yeah, like differential privacy is like good. It's definitely better. Like it's better to do something than nothing. But it's like, again, not interpretable. It's kind of like putting band-aid on something that is not like band-aidable. So what I'm trying to like do is like, hey, I just want to kind of start a conversation on like what are other guarantees that we could look at for language, like other definitions. And I kind of want to start with how people think about privacy. Like if you tell me a secret, I'm not going to try and forget it. I'm actually going to remember it, but I'm going to remember that it's a secret. So like I kind of have states in my head of like, oh, this person told me this. And then I also have states in my head of like social relationships and like social norms. And then I reason about it. I'm like, okay, like, like Sean is friends with this person. So like, it's probably okay to share this information, but like not this and this and this, or like, so I have like a mental model of how to reason about things. And like, that's how I do it. And I feel like as we're like using these agents in like more setups, and they're like also multi-agent setups. So like you have agents negotiate with each other. So you have like a bunch of language models that are like constantly talking to each other. It's really important to like see if they can keep secrets and how you can make them do that, and like how you can get them to reason. And the like prerequisite for that is to actually have like a data set or like a task that you can like use to probe and be like, oh, okay, so this is like the human norms of like privacy and secret keeping, like these topics, this is how it's going. So like one of the things that I'm trying to do is to just like build a task and like a data set on that, and then see where we can like use maybe theory of mind or like reasoning to actually like get models to like get closer to this. You definitely won't be able to get guarantees like this, but I think that it's like closer to how humans perceive it, which would be like nice to get. And then like you do one work, someone else does some work, and then like eventually it all culminates in like maybe like we can build a guarantee on it. So but someone has to start doing something. So that's like one of the directions that I'm looking into. It's just like hopefully get models to reason about privacy. And but like on the other hand, like again, this is like a very kind of long, far out goal. Like it's not going to be easy. I feel like in the meantime we do really need to make our differentially private algorithms better, and like kind of encourage people to use them. So one other line of thing that I really want to do is to just like do human studies on like trying to explain to people what the risks are for their data, coming up with ways, because again right now we have attacks and like they give us some numbers of like, oh, how bad this is, but like you can't really explain it to people, and then you can't get informed consent when you can't tell them what you're doing with their data. So I feel like how to better explain these to humans, and like what they like, how willing they are to share their data, and like all of all of the things around that are like one interesting kind of HCI aspect of things to look at. And then on the other hand, I also really do want to continue working on differential privacy and like coming up with like more data efficient methods and like better like initializations, just so that like we can kind of close the gap, at least in terms of like accuracy or utility, between like doing differentially private training, because there is still a gap, and it's not small, especially like if you don't have pre-trained model, the gap is still huge. So how you can like do that, that's another thing that I'm thinking about. And maybe even because I do have like some hardware background, I'm kind of thinking of how we can kind of solve the problem with the whole per example gradient thing, and like make the whole like computation faster, because it's still slow. It's better, but it's still slow. So I'm kind of like also thinking about that, of like how we can like maybe build something that is like faster. But yeah, that is kind of where my head is at, like
I see.
overall.
Yeah.
Yeah.
Yeah, it seems like full stack privacy in the sense that like the first idea is kind of like it's kind of at the output level, in the sense that like now that the models are getting better, they might have these like more nuanced things that they can do, like leak a secret or something, and we want to be able to protect against that. Then at like the training level, you want to train the model in a way that gives you these like really strong formal guarantees. And then at like the hardware level, we want to be able to do that fast.
Yeah, no, yeah, exactly. So it's like on different levels. But I do really want to do like stuff that are not necessarily like privacy. Like I've done some work on like fairness and ethics before, like hopefully
Mm.
like more of that on just like probing models. But I'm also just still very excited about the whole privacy aspect of things. I feel like there's still enough, like there's still a lot of work to do there. But I definitely like I want to keep this whole like I try not to just do one thing. I really
Mhm.
like it's riskier, and it's like, but I my whole thing with the way I work is like I want to do stuff that are like that is fun, and I don't really care if people don't care about it. Because when I started doing privacy, people weren't really like doing, like, even right now, like people are caring, and everyone is like, oh, you're so lucky to be doing this at this time of, like, people care about privacy. And I'm like, well, I started it a while ago and no one cared back then. Even right now, I was talking to someone and they were like, everyone is saying that privacy matters, but no one is willing to do any work. And that is also very, so, but hopefully, soon people do more work. Yeah.
Yeah, I guess we have to move to the last two questions that are asked on every podcast. So the first question that I always ask is if you think of your PhD as being a kind of optimization problem. And so with an optimization problem, we have an objective function. What would you say was your objective function kind of during your PhD? And then do you think it's changed now? So some examples might be like, yeah, just like scientific curiosity or like working backwards from some, concrete goal or yeah.
Yeah, I feel like, okay, I'll the true, like, the true objective function was like, I wanted to do something that, like, I would not, like, I would want to wake up to do it. Like, that's for me
Mm.
like a huge deal, because I don't like being an immigrant and everything. It's like you don't normally always have a lot of motivation. Maybe you have a lot of sad, lonely days. And for me, it was like my research was always the thing. Like, most people get, like, a lot of people get like depression or anxiety from their work. For me, it's always been the thing that actually calms me down, like, from everything else that is like hard in life. So I really try to pick problems that are like, I want to wake up in the morning excited to work on them more, and like not waking up and being like, oh God, I have to like run this experiment again. Oh, like, it's, whenever I feel like it's going in that direction, I mean, it's normal. Everything kind of, you have those days, but like whenever I feel like, no, this is like really not fun anymore, and it's actually like making my life miserable, like, I try not to do it. So I really like try to do stuff that make me want to wake up for them. But again, but like, for a part in my PhD, being an immigrant, I needed to get a green card. So I needed to get citations and a lot of papers. So I also needed to do stuff that I knew would get citations so that I could like make it to the cap. So that was also like, I'm being perfectly honest, like that was one of the things, was that like I really had to make sure that like I get enough citations by the right time. But I feel like I
Mhm.
got lucky that the thing that I was doing kind of compounded itself. So I didn't end up having to like jump over hoops, or what the expression is, to get that to happen. Like, it kind of happened. Yeah, so that was the thing. Yeah. Was there another part of the question? Sorry, I forgot.
I mean, I guess has anything in your kind of objective function changed since the PhD?
I think, like, yeah, after I did get the green card, I became more free in what I wanted to do. Like, I just like focused fully on doing things that I would really really enjoy. And I think it's also like, when you're still in the middle of your PhD, it's good to do things that like your advisor does as well, so that you get more guidance, and you also like get like more feedback, and like, it's like good to like maintain a good relationship. So I like, although what I was doing was like different from what Taylor was doing, I really tried to like sometimes like I would just do stuff that he would like propose, and I think that was also good because it gave me a different perspective. And also, like, it kind of matched well with the rest of it. So I think that's also good to not focus on one thing. A lot of people say that, oh, like, for your thesis just do one thing. I think it's good to like do a couple other things that are like entirely different. It really gives more perspective. Yeah.
You might have answered the last question, which is one piece of advice for new researchers. But if you had other advice,
I actually have one other thing. It's the thing is like, I see a lot of people, like, I really try to do like a lot of outreach and stuff, especially because when I started doing privacy again, I was in a lab that I did not get like it was like architecture. I did not really get any support on it. So I really had to like figure out and like build a community myself. And I think I do get a lot of like people that I like meet, or like I get a lot of like DMs and Twitter, that people who want to start doing research and they don't have PhDs, they're not in PhD programs. And right now it's really, really hard to get in an ML or an NLP PhD program. It's kind of like, it's this thing which doesn't, like, you need papers to get in. And then if you're not in the US, it's like really hard to get into somewhere to get papers. So it's kind of just like the barrier to entry is like, it's really difficult for a lot of people, that like, you need at least like one paper. So one thing that I like tell people is like to really take online communities and open source communities seriously. Like for me, there was this community, I mean, it still exists, Open Mind, that I feel like I owe a lot to them, because it was just a group of people who were interested in privacy, and then we would like gather together, we would like come up with ideas, and like just like it was completely independent of any organization, and we would like test things out. And that was like both really fun, and it helped us like get some like workshop papers going, and like finally some conference papers. So I think that like if you want to enter and like you don't really have a background, you're not in a program, you're not connected to like, giant like, or like, academic setups or like industry, like using like getting help from online communities is really helpful. And also just like reaching out to as many like people who like, who would be who are maybe from similar backgrounds. People are more inclined to help people than people normally think. Like a lot of people are afraid of asking for help, but yeah, there are some people who would like shut you down, but I feel like most people are kinder than we imagine. So it's like it's okay to walk up to people and just ask for help, or like DM people, or like email them. You might send like 10 emails, you would get one response, and like that might be something that like changes things for you. It's like all it takes is one person giving you a shot. So I think like try your hardest and like make all the connections, and like, online communities are like really good for that. Yeah.
Yeah, definitely reaching out to people. And the other thing to remember is like some people might say no or might like miss your email because they're really busy and like they would really want to help. So don't
Yeah.
like necessarily take it as a
Yeah,
yeah.
yeah, exactly. You
So
should not.
sometimes you just have to try a lot. Yeah.
Yeah, yeah, that's a really good point. Yeah, it's not at all personal. Yeah, yeah, that's so true. Right.
Yeah. Yeah, thanks so much for coming onto the thesis review. And yeah, this was really fun. So thanks for taking all the time.
Yeah, thank you again for having me. This was really fun. Like I feel like every time I talk about like my work or something, it gives you a new perspective too as to what you're doing. It's like kind of like I'm getting to detach from it and get a look from outside. So it was really interesting. Yeah.
You tapped into the thesis of the thesis review right there.
Yeah.